And they said, "Let there be light." Hello, YouTubes. Welcome back to Workshop Wasteland. Today is a pretty successful and exciting day as we finish up our dynamo generator. This is part 3 in a 3-part video series, so if you haven't seen the other 2 parts, go back a little bit and check those out. This has been a lot of fun. I've had an absolute blast machining this little kit. It's pretty inexpensive and perfect for a beginner. Easily completed in a weekend, and in the end you have a functional DC motor or generator, depending on your application. So if you enjoyed this, please don't forget to like, comment, subscribe, ring the bell. It would sure help out. And let's hop over to the drawings and take a look at some of the parts we need to finish up on this generator. So here at the bench you can see this is the eyelet piece that we're going to make. It says 1/4 inch diameter ball, and you can see the rest of the measurements there. I don't have a ball turning fixture of any type to use on my lathe, albeit one of those would be pretty cool. However, I effectively made a ball which we're going to be able to use for this. And to do that, I guess this would be called a forming tool. It's by no means a tool and die maker setup, but worked pretty well. So let's hop over to the lathe and see if we can't turn this piece out of the 1/4 inch stock that was given to us. So as you can see, got the 1/4 inch stock in there. I'm using a collet block for this because it's a little bit easier to swap the part around. As with any operation, we're going to start off facing off the end. So let's see what that looks like. Alright, get my tool swapped out here for this form tool that we made, which works surprisingly good. I'm actually kind of impressed with how good it did. So what you need to do here is come in far enough that this little outer part of the ball is going to get cut whenever we run the tool in. So we're barely over the edge, which is great. And let's see what this looks like. It's not perfect. It wants to grab a little bit, probably because there's such a wide blunt face on this. There's no kind of back rake or anything like that, so it's not perfect, but it works, and that's all that matters. Let me give you a little bit different shot here for that. Got you in frame a little bit better there. Like I said, we just want to barely have this tip be cutting the outer edge, so we form that ball all the way to the middle. So here we go. As you can see, that worked pretty darn good. I'm going to stop right there. I know there's a little tiny spot right there that's not cleaned up, but I want to use this as part of the clamping in my collet whenever we flip this piece around, which is what we're going to do next. So let's get this flipped around and finish out the rest of the features. Next operation then is to turn down the diameter and the length for the little shoulder at the top of this part. The plans call for 7/16 long, which is 437, and we're going to shoot for that. And then the diameter is supposed to be .096. I'm going to make it 0.1 because that's what fits in the hole of my cast iron part. So here we go. All right, there's 437 deep. I'm taking light cuts here because it's not being held by a whole lot in that collet chuck, and I don't want it to pop out. I'm actually going to go closer to the collet, and then we'll trim it back later. I'm going to go to right there. So now what I can do is re-zero my indicator and come out 437. There's 437. Go slow here. This is a lot of stick out. And this tool likes to grab a little bit, so you need to be very careful here. Clean the end back off. All right, now we have 437. I'm going to go to turn this down. I'm going to turn the part down to 1.0, and then I'll bring you back in for the threading. This is my setup for threading on the lathe. You could of course single point thread this, but there's a lot of stick out on that little tiny part, and a 3/48 thread is really fine. So this seems to work well for me. As you can see, I have my tailstock chuck pushed up against the back of this tap, or I'm sorry, of the back of this die, and I'm just applying some light pressure to get us started, and then I can turn the lathe over by hand, and this typically works really well, especially for a tiny thread like this. Then once it's started, as you can see, just let the thread pull the tap in. And I cut a bit of a shoulder, so we'll run up against that. And that's about all that it takes to cut this thread. As you can see, as you can kind of see, it does a really nice job. Now my camera doesn't want to focus on that. There you go, you can see a little bit better. But that's a pretty nice thread, and that's just about it for this part. Let's move over to the mill and do the other features. As you saw in the plans, they call for this to be machined flat, with leaving 1/8 of an inch behind. So 1/8 of an inch is 125, and we need to take 1/2 of an eighth off of each side. So 1/2 of an eighth is a 16th, which is 62 thousandths. I'm going to take 60, which is fine. Then the only thing we have left to do is drill the hole down through there, and we'll be done. So we need to come down, touch off on the part, zero out the DRO, take 60 thousandths off. Then because I'm using a collet block, we can just flip that thing over 180 and come down to the same depth, and we'll be effectively perfect. So see how that looks. All right, there's one side done. Let me get this flipped over. We'll do the other side. Here's the other side. Like I said, got the collet block flipped around. It's square, sitting on a parallel, so we're all good there. And now we can ensure that these two surfaces are parallel to each other, which is a really convenient thing about using these collet blocks. Last thing to do then is to drill this 1/8 inch hole down through the middle. All of this is purely aesthetic, so what I'm going to do is just get it centered up by eye the best I can, and it'll be good enough. So let me get that set up for you, and we'll drill that hole. Start off here with a center drill. Like I said, I got it centered up pretty good by eye. It doesn't have to be perfect, but we'll give it a little dimple here. Now we'll come back with an 1/8 inch drill bit and drill down through there. You need to drill pretty carefully because there's no support under here, and it's in the collet block by that threaded piece that we had left. So if you put much of any pressure, there's a good chance you'll just bend this and then you'll ruin this part. So we're going to go nice and easy here. All right, here we are, nearing completion on our little dynamo build. Hopefully this inspires you to buy a kit and maybe potentially follow some of the tips in my videos and build one of these for yourself. It's been a whole lot of fun. I've actually really enjoyed it. The plans are awesome. The kit goes together pretty quickly. It's easily a weekend project. And like I said, it's been a blast. So thanks for following along. And really all we have left to do is some final assembly. I'll get you in for a closer shot, show you a few small parts that I made off camera. Very straightforward, basic lathe operations. and we'll take a look and get this thing together, give it a bit of a bench test. So off camera, I made these little pieces which are for the electrical wires to connect to. I quickly machined up another forming tool to get in there and form those balls for that little wire socket. It also doubles up as a brush holder. There's some insulating paper in here that the kit comes with to hold the brushes and keep them insulated from this casting. Again, the plan's really detailed. I didn't exactly follow them. I just made something close, but you get the idea. Made me a little aluminum slug, which holds the magnets apart. I'll show you that momentarily. And then this is a little pulley. Again, nothing special. Made that up. But next thing we need to do is, I already did it on this one, press this little bushing in. Again, kit supplied bushings. We bored the 1/4-inch hole. Bushing's going to press into there. They fit pretty snug. I think snug enough. There's not really much of a load that's going to try and pull them out. So I'm going to go press this in off camera real quick. Just wanted to show you that's how it goes together. Very, very straightforward. Alright, got that little bushing pushed in there. Again, nothing special. If it were loose, you could have used some Loctite retaining compound. Shoot, even some super glue would probably hold that in just fine, but we're good to go in that sense. Next thing we got to do is take our little eyelet and this aluminum disc that the plans tell you to make. The aluminum disc goes here in the bottom, and the eyelet is going to thread into that. This is going to hold the magnets apart at the top whenever we slide them in here. So stick this in, get it lined up where you want it. I'm going to use pliers and make sure it's good and snug. Just be careful with that. It'd be really, really easy to twist those threads off. Then as you can see, we have our magnets here, which will, right now they're stuck together. That seems to be the correct orientation. Just going to slide them down in there. And you can see in there that little aluminum spacer holds them apart at the top. And then we're going to slide this spring clip in to hold them out. That way they don't get in there and rub against our rotor. Let me grab a screwdriver quick for this. Just be careful with this little clip. It has a good bit of spring tension, and it could easily go flying across your shop somewhere. And obviously if it goes flying, it'll be lost forever. You'll never find that thing again. And then the plans tell you to center the magnets up. I'm just doing it by feel. Looking for an equal gap on each end. So that's pretty darn close. Next thing, the brushes took a little bit of finessing and tweaking. But you have to get your rotor in between the brushes. This is really hard to show on camera. But you're going to get them in between like this. So they get up onto the commutator. It's supposed to be centered up. You're supposed to center the brushes on this gold colored part in here. This is the commutator of the motor. So they're supposed to be centered up. I had to bend them a little bit to get them there, but that was easy enough to do. And then I punch marked. You can see there's a single dimple right there. And here on the bottom, a single dimple and 2 dimples. So I punch marked those. That way I could get this line back up in the event we didn't do a great job at machining the bolt circle on this casting. It'd be easy to line up. So we get that together. We're going to slide our other end bell on. I'm going to put the 8 screws in there off camera. They're pretty fiddly. And then we'll go hold this thing down in the vise and see if we can't give it a test spin and light a light bulb with it. Alright, set up over here at the vise. Got this thing all assembled. I have my multimeter on the beep setting. Testing for continuity. It'd be a good idea to test between your posts right here and the frame. And make sure that you do not have a connection. Oops, I was touching the brush. So make sure you don't have a connection here on either one of these posts, because if you did and you put voltage to this, it would short out, or if you were using it as a generator, it would also short out. So If you have a multimeter, great. If you don't, unfortunately, you won't be able to do that. But I just thought I would point that out. Pretty good little tip. So what we're going to do, clamp this loosely in the vise. Let me grab a battery real quick and we'll try it out as a motor first. As I stated in a previous video, this thing's really just a DC motor, but if you spin this with something, it's able to produce voltage. So that's a neat feature of a DC motor. I'm going to use a drill battery. Maybe don't try this at home, but it'll work just fine for this. Works good that direction. We can flip the positive and the negative around, and it'll spin the other direction. I don't know how well you can see that in the video, but zoom in a little bit more. But works good as a DC motor. That was a 12-volt drill battery. Again, maybe not the best way to power it, but certainly works. Now I do have plans one day to put this with an engine. I have my little hit and miss engine that I built, but I can't get it to run perfectly consistently, or at least not enough to be able to reliably power this generator right now. So I'm going to spin it up with the Dremel just to prove that it can also be a generator. This is a 12-volt DC light bulb. It's actually for a gauge for a vehicle, but 12-volt bulb nonetheless. So let's spin this up with our little battery-powered Dremel here. As you can see, actually works quite well. That light bulb was probably on the verge of blowing. I don't know how many RPMs that was spinning, but obviously enough to power it quite well. So obviously works perfect.